You have used the equation Fg equals mg many times to calculate the weight of an object on the Earth's surface. Now you have learned that the weight of an object on the Earth's surface is Fg equals g me mo over r squared EO, where me is the mass of the Earth, mo is the mass of the object, and reo is the distance between the centers of the Earth and the object. Newton's law of universal gravitation. The force of gravity is proportional to the product of two masses that are interacting and inversely proportional to the square of the distance between their centers. So Fg equals gm1 times m2 over r squared. Here is the question that we will be solving. You need to conceptualize the problem first. The weight of the astronaut is the gravitational force on them. The relationship Fg equals mg, where g equals 9.81 meters per second squared, cannot be used in this problem. The law of universal gravitation applies to this problem. You can now identify the variables and the constants. So you know that mm is 7.35 times 10 to the power of 22 kilograms, ma equals 65 kilograms, and r equals 1.74 times 10 to the power of 3 kilometers, which is also 1.74 times 10 to the power of 6 meters. And it's implied that g equals 6.67 times 10 to the power of negative 11 newtons per meter squared over kilograms squared, and you have to find the unknown, which is Fg. You can now move forward with this strategy. You apply the law of universal gravitation, and you substitute the numerical values and solve. Fg equals m1 m2 over r squared, so Fg equals 6.67 times 10 to the power of negative 11 newtons times meters squared over kilograms squared, times 7.35 times 10 to the power of 22 kilograms times 65 kilograms over 1.74 times 10 to the power of 6 meters squared. And this is equal to Fg equaling 105 newtons, so you can say that the weight of the astronaut is approximately 105 newtons. Now you validate the solution. Weight on the moon is known to be much less than on Earth, so the astronaut's weight on the moon is about 1/6 of the weight on Earth, 6.65 kilograms times 9.81 meters per second squared is approximate to 638 newtons, which is consistent with this common knowledge. A common mistake is not doing unit analysis before doing your solution. So newtons equals Newton times meter squared over kilograms squared times kilograms over meter squared. This simplifies to n times m squared over kilograms squared times kilograms over m squared, which simplifies to newtons equals newtons. And you have to note that the value of universal gravitation constant is g equals 6.67 times 10 to the power of negative 11 newtons times meter squared over kilogram squared. Here is the marking scheme. 1 mark for conceptualizing, 1 mark for giving your known, implied, and unknown, and 2 marks for solving, which equals to 5 marks.